Good morning to one and all. So, once again, I welcome you all. This is Dr. Nishant Sharan, designated as Assistant Professor in the Department of Electronics and Communication Engineering in the MITS College, Madanapalle. The last session in part 1, I have discussed the topic called as electrostats, and there we discussed basically what is charge with some live examples from our daily life we have discussed. You can refer to the video. Also, the very important point like the Coulomb's law was discussed. As you can see, my flow of presentation starting with the introduction, we covered with the electric charge, then Coulomb's law, and also last but not the least, there was a problem solved that how you can compute the force of attraction or repulsion acting between the two charges. That was the statement of the Coulomb's law, which basically states that, just for a recall, let's have a recall. The Coulomb's law, which basically states that force of attraction or repulsion between the two charges, Fe, was equal to 1 by 4 pi epsilon times Q1, Q2 divided by r square, and since it is a vector quantity, so here there was a direction ar hat. This we discussed in the last class, and where we know that this constant for the air, that's very important, k, that is equal to 1 by 4 pi epsilon naught for air, is essentially 9 into 10 to the power 9. This was discussed in the last class. So moving ahead, today we will see having the focus on electric field. This is the topic which we are looking forward today, electric field. So let us start, let us begin the electric field, the concept of electric field. Hope you all are ready. So let us start. Electric field. If you see and try to imagine a situation that a charge is placed at a particular coordinate or at a particular point, and you bring another charge in that vicinity of the previous charge, then what will happen? The charge which you are bringing towards the vicinity of the previous existing charge will experience the force. That's very interesting. So what I said, if you bring the charge, let us call it a test charge. So let us call it as a test charge. I'm bringing a test charge to a charge which is already present at some coordinate. So the test charge experiences a force. Then question may arise, what is the physical entity which is responsible for exerting the force on this test charge? That's really interesting. So we will investigate that. So what is happening is that, if you see here in my slide, whenever you are putting a positive charge, these lines of force, they go away from the charge, and for a negative charge, they comes towards the charge. Now suppose I bring a charge from here to either this side or towards this side. Then either this one or this one, depending upon which one I am moving and which one is remaining static, will experience the force. So that force experienced is due to the presence of electric field near the vicinity of charge. That is a very, very important point. So if you see, the electric field that exists at a point is the electrostatic force experienced by a small test charge Q naught placed at that point divided by the charge itself. That's very interesting. Electric field. So we are studying a new physical quantity, E for the electric field, since it is a vector. And very simple definition is force experienced by the charge per unit test charge. That's very important. So field is always created due to presence of another charge, and the force is exerted on the charge due to the field created by the another charge. More it will become clear if we will see some problems very soon in the next upcoming 5 to 6 minutes. Let us see. So again, whenever there is a physical quantity, we always have some SI unit. And since the quantity here is the force per unit charge, So all of us know from our basic school level physics, what is the unit of force? Yes, yes, that is always Newton. And what is the unit of charge? Very simple. We all know that's Coulomb. So what should be the unit of electric field? If you see here, what should be the unit of electric field? So unit of electric field will be essentially, since already we discussed, that is force per unit charge. So force is having the unit called as Newton and charge is having the unit called as Coulomb. So definitely it can be written as Newton per Coulomb. Later on, we will see that this electric fan field can also be expressed in terms of, there's another unit called as volt per meter. That we will see in the upcoming lectures. But for the time being, let us be contented with the unit Newton per Coulomb. And I believe that that makes logical. So I believe that is okay and that sounds logical also. So fine, let us see that what we are going to have the idea next onwards. So first thing is that before going to the equation, so just like the force equation in the vector form, here also you can have the vector form of electric field. So how? Once again, let us recall. That is what we have done earlier. So it's very easy. Force we have written earlier. It was K Q naught upon R square AR hat. We are aware of this in the last class. Then today, what we discussed that E is equal to F over Q naught, or it may be the QT, where Q naught is essentially test charge. That's very important. The Q naught is essentially test charge. So if you use this equation, E is equal to F over Q naught, then this becomes, the equation becomes, expression for F is K Q naught, Q naught gets cancelled out, and it becomes K Q over R square AR hat. So very simple. So only one charge. So the electric field will be due to only one charge. If you see, that is KQ by R square. That's very simple. So this is what my equation is basically entitled here. Electric field is KQ by R square R hat. And again, if I say about the R hat is the unit vector. That also we should know. That is the R hat is the unit vector along the direction of R. That's also important, along the direction of R. And of course, unit vector, from our school level physics knowledge, we know that that is nothing but vector by its mod. That's also we have come across it. That is a vector over its mod. So this was all about the equation of the electric field. That is what. So let us first, before we go for the some good problems, let us see the key points about the electric field. So the first point is that it is the surrounding charge. That's very important point I would like to highlight, that it is the surrounding charge that create an electric field at a given point. So two keywords are here to be noted specifically, that always due to presence of a charge at a certain point. So please be noted and be careful that due to the presence of a charge at a certain point, always there will be an electric field. And due to the presence of that electric field, if you bring the another charge into its vicinity, it will experience a force. That's very important. So what I mean to say, that we will see in the upcoming slides in a much better way, but here also these two keywords should be in your mind. Then, as I said, that electric field, this side if I write, electric field is F over Q. So definitely, if I want that to compute the force, it will be Q times electric field. So that is also another aspect. F is equal to Q times E. Not a very complex thing, rather a very, very simple thing, that F is equal to Q times E. So that is another aspect. Then another aspect is there. if you see, suppose there are three charges present at three different locations. For example, one is here. Let us suppose another charge is here, another charge is here due to with the help of some coordinate. And then I bring the another charge. Let us call this one as a Q1, Q2, Q3, right? Or suppose I want to compute the field due to this Q1, Q2, Q3 at particular point P. So let us suppose that there is a particular point P with the some coordinates. So the total field at this point P will be the net sum of the field due to Q1, Q2 and Q3. What I mean to say? I mean to say that total field at P, that is E total at point P, would be simply electric field due to Q1, that is what I mean to say, plus electric field due to Q2 plus electric field due to Q3. And we are familiar with this, that this is called as principle of superposition. That's very important. This is also known as principle of superposition. So another important aspect one should keep in mind, that at a particular point in space, each of the surrounding charges, that's very important, each of the surrounding charges, they contribute to the net electric field that exists there. Yes, that is what I mentioned. If you are having the three charges, Q1, Q2, Q3, and you are interested to find the electric field at point P, so E total at the point P would be field due to Q1. So first you will have to compute field due to Q1. How? Yes, definitely. That will be a question, how. So how you can compute, that we will discuss with the problem. And then electric field due to Q2. Yes, again, how? So again, the same process as you will compute for Q1. And then electric field due to Q3. Yes, the problems will make it more clear. So let us move on. Yes, there is another concept of the electric field lines. So what does this electric field line show? So electric field lines basically shows the strength of the electric field. For example, if suppose I'm taking a positive charge here, and we know that electric lines of force for a positive charge, they go away from the charge like this. They go away from the charge. So if they go away from the charge, so more is the length of line, more is the strength of the field. That's very important. So just this indicates the strength of the field, and also direction, definitely direction. So the more denser is the line, as you can see, more denser is the line, stronger is the field. And if you want to find the direction of the electric field, you take the tangent to the curve. So another important point, that tangent to the curve gives the direction of electric field. That's also very important, direction of electric field. We'll talk more on this. There are some more properties which I am not highlighting today here. We will have the, in another session, I will highlight some more property, but these are the basic ones. Okay. So just let us see. All of us know what is a conductor. Think for a moment. All of us have covered in our school level physics. What is a conductor? Yes, conductors are nothing but which conduct electricity easily. They are having a large number of free electrons. That's right. So conductors, you know, there are the three categories of the material. One belongs to conductor like metals, another are the insulator like wood, rubber, and there is a category called as semiconductor. And nowadays, nobody is unaware of semiconductor. The mobiles in your hand, the various different devices, your television at your home, you are having the different screens, all they belong to the semiconductors. There is a huge role in the field of communication to evolution of communication. There is a huge role of semiconductor. Anyway, we will talk more on that semiconductor in some other subject session, but coming back to the point, that conductor. So inside a conductor, what happens? Inside a conductor, the electric field is always zero. Why? Yes. This for today, I'm leaving you to just explore this. Why? Because all of you have covered at your school level physics. You can just think of it. You can Google it. Nowadays, nothing is beyond the reach, um, anybody's reach. So knowledge can easily be gathered from all the sources. So just I leave it to you. Just try to explore, or else we can discuss it in the next session if any query is there on my video link. So, but important concept is that inside the conductor, electric field is always zero, and the charges reside on the surface of conductor. Yes. Once again, I repeat the same because it is very, very important concept. Electric field inside the conductor is always zero. Is always zero. And the charges, they reside on the surface of conductor. So please be careful. That is what these 2 points are illustrating. And then excess charge accumulates on the sharp point. So that's very, very important. Very, very important. And you will realize its importance. I'm having a question for you. See, a very practical question. Where are you safe during a thunderstorm? Inside a car or outdoors? Suppose you are traveling and suddenly very heavy rainfall starts. And along with that, a huge thunderstorm, very huge thunderstorm. Imagine yourself in a situation. What should you do? Whether you should reside inside the car or you should come out of the car and go to some shelters like the soft shelter or something like that. Where? Where you do feel safe? Pause the video, think for some seconds, and then you can answer. Yes, just think for 10 to 20 seconds at least. While discussing this question, till now I have found that more than 70% of the students, they answer the outdoors. They think that inside the car, it is dangerous. It may lead to the death or some fatalistic cause. That is what the people used to answer outdoors. But you should know, this is not a correct answer. This is not a correct answer. You may wonder why. Yes, I will explain. So first you see the answer. Where we are safe in a car. Why? The question can be there, definitely. Yes, because the body of the car is made up of metal. First thing, body of car is made up of metal, right? Then you will say, what is the new in it? Everybody knows that yes, body of a car is made up of metal. Yes, definitely. New is that metals are conductors. Okay, then you will say, again, what is new in it? That we know, metals are good conductors. Yes, definitely you know. Then, but you have flipped or you have missed out a point. What is the point you have missed out? The point you have missed out is that inside a conductor, that is just now we discussed, electric field is zero. That's very, very important point. Electric field is zero. So definitely, when thunderstorm is there, lightning will happen, and that lightning, if it will strike with the metal body of the car, all will just become zero. So inside the car, you will remain safe rather than, because our body can conduct electricity, but inside car, you will remain safe. So now I believe the question has been answered very clearly and properly, that inside a car, we remain safe. Okay, so the correct answer is in a car. So that I believe is now how the conceptually the things have gone more beautifully. So see, whenever we study a topic, we should try to answer the questions belonging to the real life scenario. That's very important. Okay, so now we see that, as I told you earlier also, that we are having the superposition theorem. So what is the superposition theorem? if you are having the more than one charge, suppose this is Q1, this is Q2, and we want to compute the field at point P, then first you have to compute the electric field due to charge Q. And you know, field due to the positive charge, what happens? It goes away from the point. Be careful, since it is positive, so it goes away from the point. Okay? And due to negative charge, it should be towards the point. So here both are positive. That is why this is also going away, because both are positive. So Q1 and Q2 both are positive. Here, suppose, for your just knowledge, suppose this one would have been minus of Q. Then what will happen? Yes, very rightly said. If this one would have been minus of Q, then field would have been towards the point. Instead of going away, it would have come towards the point. So if it was the minus Q, it will come towards the charge like this, like this. So it will not go away from the point. Sorry, like this. So that is what it will come here, not it will go away from the point. So this is the what the conceptually you should know. This figure and some problems I have taken from the book, a good book you can refer, that is the Electromagnetic Engineering, the author GSN Raju. So I will take the 2-3 problems from that book only, and you can also refer for your more practice and knowledge. The Electromagnetic Engineering by GSN Raju. So let us see the problems one by one. First, I am taking a very simple problem, very simple problem. What is the problem? That Coulomb's force is given. So first you see what is given. I will write here. The given quantity is the force. So let us try to understand the problem. Force is given. So force is given as 2ax hat plus ay hat plus az hat. Okay. So, and this is acting on a charge of 10 coulomb. So Q is given 10 coulomb, no problem. Find the electric field intensity. Yes. First you have, and what are the quantities you have to find? You have to find the electric field. Good. Then mod of electric field. Okay. And then direction of electric field. So see the notations first. First is the vector electric field, then magnitude of electric field, and then direction of electric field. This 3 quantity. Let us solve one by one. Part A, electric field. So how to solve? We know, we all have studied just now. F over Q. The formula says F over Q. That's okay. F over Q. What is F? F is 2ax hat plus ay hat plus az hat. Okay. Over Q. Q is what? 10 coulombs. So very easy mathematics. 2 over 10. So 2 over 10 will fetch you the 0.2 without any problem. 0.2 ax hat. Here it will be 1 over 10. So means 0.1. Not a big deal. And 1 over 10 again 0.1 az hat. This all of you understand very clearly. The next one is that I have to find the part B. I have to find the mod of E. So mod of E is also very easy. All of you know, if there are the 3 components of a vector, then how to find its mod. If you know the 3 components, x component, y component, and z component, then how do we find the mod? That is very easy. We used to write 0.2 square plus 0.1 square plus 0.1 square. And that you can, with the help of calculator, you can calculate. One more thing, I have missed out here the units. Units must be there. It should be Newton per coulomb. Then mod of this, if you compute, you will get a value like 0.2449. That's what the mod. So again, this one will be also Newton per coulomb. And last but not the least, I have to compute AE. That's the another quantity which I am interested in, AE. So AE means direction. So direction, you know that this is a unit vector. So unit vectors are nothing but vector divided by its magnitude. So vector is the E divided by mod of E. That's very simple. So what is E? E already we have got, that is nothing but, what is E? That is nothing but 0.2, and this I will divide by magnitude 1 by 1. Here itself magnitude is 0.2449. So 0.2449, definitely AX will remain as it is, plus another quantity 0.1 divided by again 0.2449. Why? Because I need to divide by the mod. And mod is, what is the value of mod? Mod is 0.2449. Yes. So here AY will be there. Again, it will be 0.1 divided by 0.2449 AZ hat. And this you can solve. I'm just leaving this task for you because this is your simple calculation. Either you do it manually, or if allowed, you can take the help of calculators. But this you can do, so I'm not doing it. And so this is just a task for you. So this is one of the problem I have solved, which is definitely an easy problem. And in the each and every detailing of the step might help you. You can take up more and more problems like this. Let us see some more problems. In this problem, what is there? It is showing that if a charge 2 microcoulomb is located at one point and there is another charge of 1 microcoulomb which is located at the another point, you have to find the electric field at P2. That's the question. So how to deal with this question? We have to find the electric field at the P2. So that is very, very simple. If you see the electric field at the P2. So let us see. First, let us see which one is our test charge. This concept of the test charge I have discussed. So which one is our test charge? So if a charge of this is located at another charge is located in free space, we have to find the electric field at P2. So the charge which is located at the P2, that is what I will write here. So one of the charge QP, P2, better let us write P2. So this is 1 microcoulomb. So I will write this one as it is. 1 microcoulomb means 10 to the power minus 6 coulomb. That's very simple. And this one is located at 0, 1, 0. And there is another charge QP1, that is also 2 microcoulomb, and this one is 2 into 10 to the power minus of 6 coulomb, and this is located at 1, 0, 0. No problem. 1, 0, 0. That's very simple, right? And then we have to find the field at the P2. So that's very simple. If we have to find the field at the P2, so what will be the field at P2? So field at the P2 will be, you see, just now we have studied electric field at point P2 will be K, which is 1 by 4 pi epsilon naught into Q, that's very important, into Q divided by R square, and that also we will have to calculate very carefully, AR hat. This is what the formula says. So now the question arises that which Q you will take. 2 Q are there, one is this one is this one. Which one should I choose? That's the very important point. Yes. Think for a moment, which one we should choose? 1 microcoulomb or 2 microcoulomb? 1 microcoulomb, sure, or 2 microcoulomb? If you are saying 1 microcoulomb, sorry, is not the right answer. 2 microcoulomb. Why 2 microcoulomb? Because we have to calculate the electric field at P2. So electric field at P2 will be due to this charge P1, not due to this charge Q2, because Q2 itself is located at P2. So electric field will be created by this charge Q1 at some point P2. So first thing is that here it should be QP2. That is what, QP1. So I mean to say that 2 microcoulomb. So let us try to complete this one. Now it's very easy. So first you will calculate the R square, which one now you know, the final minus initial. So that would be simply you will be getting AY hat minus AZ hat. That's very, very easy, because this one I can write AY hat. This one I can write AX hat. So I think some mistake, 0, 1, 0 and 1, 0, 0. So 1, 0, 0 means AX hat and this one is AY hat. So it should be AX minus AX hat. This should be, I should write it more clearly, that it should be AY minus AX hat, definitely. So this would be R, not the mod of R square. Then mod of R would be, that's very easy to write. Let me rewrite this. Sorry for this fumble. So it would be the R. Mod of R would be very simple. 1 square plus 1 square, that is square root of 2. That is not anything big. And then now we can plug the values. That's very easy to solve. We can plug the values. Electric field, K is 9 into 10 to the power 9. Not a problem. Regarding Q, already I have discussed that how you can find the Q. That's very, very simple. Into 2 into 10 to the power minus of 6. And then definitely you can plug in here divided by R square. So mod of R is the root 2. So mod of R square will become root 2 square. And here you can plug in this AR hat also. So AR hat would be also very easy to write. AY hat minus AX hat divided by root 2. And it's very easy to compute this whole that you can find. I'm just writing the answer here itself in a very simple manner. 6.34 approximately times AY hat minus AX hat. So this is how you can see, you can find or you can solve a problem that how to find the electric field at a particular point. So this is what we have solved, this one. Let us see the one more problem for today's session. So one more problem I have not written here, but just I will frame a question that let us suppose that what is given is that, I'm having the charge Q1. Try to again understand. I'm having the charge Q1, which is just 5 coulomb. Okay, no problem. I'm having the charge Q2, which is the 1 nano coulomb. Okay, nano, all of us know what is the value of nano coulomb. That is 10 to the power minus 9 coulomb. Okay, then the question can be there. Find or determine. I'm writing the question. Determine. And what is the question? That determine electric field E at some point. So let us also define the point. Point I have not defined here. Let us define that this is the point, suppose minus 1 comma 1 comma negative of 3. The location of Q1, I mean to say. And what is the location of Q2? You can take anything, but I am taking 310. Okay. So then I have to find the electric field, and let me call this as a point P1. Let me call this one as a point P2. And I have to find the electric field at point P1. So again, similar to the previous problem, electric field at point P1, or also you can say electric field at the charge Q1. Same thing. So again, there is no such big issue here. So what we can do? So that's very, very easy. Electric field is equal to, same aspect we will do. First, electric field is equal to 1 by 4 pi epsilon naught Q over R square AR hat. This is our formula. Then first I will compute the R, which is very, very easy to compute. So what should be the value of R? Minus 1 minus 3 AX hat, you can understand, plus 1 minus 1 AY hat plus minus 3 minus 0 AZ hat. You can have a question here that why I'm taking like this, minus 1 minus 3. Why not I'm taking 3 minus of minus 1? Yes, you can have a question. Yes or no? Yes, you can have a question. Because where I'm calculating the field? I'm calculating the field at this point, right? So always it is the final minus initial. That is what is the idea. So based upon that idea, earlier also we have seen. So very easily you can do minus of, so now is very easy, minus of 4 AX minus of 3 AZ hat. That's very easy. Then it's very easy to find the mod of R. What would be the mod of R? So that also you can calculate. Already we have discussed. So it would be the positive of 5. That's very simple. So here now we can write the AR hat continuing the same, which is very, very easy. If you find the AR hat, what shall be the AR hat? You can try to write by yourself also. So what should be the AR hat? It should be minus of 4AX hat minus of 3AZ hat whole divided by 5. Yes, we know this. And then what would be the finally electric field? Just you need to put all the values. And what are those values? Values are very, very simple. 1 into 10 to the power minus 9, 1 nanocoulomb. This multiplied with 9 into 10 to the power 9 value of K. This whole divided by what? 25. Why 25? 5 square. That's very simple. Yes or no? Into 5 into minus of 4AX minus of 3AZ hat. So this, if we calculate, this will fetch you the final answer as negative of 0.288AX hat. After calculation, that you will have to do. That I'm not doing it here, the calculation part. So that you will have to do by yourself to compute the things. So this gives you the electric field like this. So this is what today we can stop here. Then you can see the some more problems how we can find the or we can use the superposition theorem. So this is what, if you have any questions, you can put your queries on this particular given link. I believe that the basic concept of electric field has come to your knowledge and you can utilize it to solve the problems. For any query, feel free to contact. Thank you. We will meet once again, carrying on forward with the next topic called as Gauss law in electrostatics. A very, very important topic. Thank you.